This is Senior Algebra, Section 9.1, the square root property. So today, we're looking at a couple different ways to solve problems that involve quadratics, square root squares, x squared, that type of stuff here. So we begin by looking at a problem we've done before. X squared equals 9. We're going to solve this by factoring. When we factor, we want to get everything on one side, get a 0 on one side. So we're going to minus 9 to each side. So I get x squared minus 9 equals 0. At this point, I'm going to factor it. Now, looking at this, there's no middle term. It's a difference, meaning subtraction of two squares, x squared and 9, which can be written as 3 and 3. So it's going to be x plus 3 and x minus 3. And remember, then we solve this. We set each of them equal to 0, x plus 3 equals 0, or x minus 3 equals 0. So we get x is negative 3 and or x is 3. So that idea leads us to what's known as the square root property. So when I have something that is squared, in order to get rid of it, I take the square root. The square root property says this: if k is a positive number, meaning we have x squared equals a number, a positive number. Remember, we can't take the square root of a negative yet. Then we get two answers here. So when I have x squared equals 9, to get rid of something that is squared, I can make two equations. I take the square root, and the answer is going to be x equals the square root of k, or in this case, the square root of 9, we'll say. Or x equals negative square root of 9. So just like we did up above, we get the same answer here. We get x equals 3 or x equals negative 3. Now, typically when we solve these, we usually don't separate it like this into the two equations. A lot of times you'll see it written like this: x squared equals 9. To get rid of something that is squared, I take the square root. Whenever I introduce a square root into the problem, in order to account for both the positive and the negative, I go plus or minus there, out in front. So x equals plus or minus 3. Same answers, just a little different way to write it. You can do it either way, doesn't matter. So now, how do we go about solving these? Well, if I'm looking at A here, I want to get x alone here. So things I need to get rid of here. I need to get rid of the 3, the squared, and the 5 here. Well, what am I going to do first? Get the squared part alone. If it was 3x plus 5 equals 11, I would subtract 5. Then I would divide by 3. And I would get x squared equals 2. Now at this point, how do I get rid of something that is squared? I take the square root. And whenever I introduce a square root into the problem, I have to put plus or minus in front of it. So I get x equals plus or minus 2. Looking at B, so in B we have 8 times something that is squared equals 32. Same idea here, get the squared part alone, just like we did in part A here. So in order to get the squared part alone, I need to get rid of the 8. It's 8 times that, so I'm going to divide each side by 8. I get x minus 3 squared equals 4. So now, how do I get rid of something that is squared? I take the square root. And whenever I introduce a square root into the problem, plus or minus. So I get x minus 3 equals plus or minus the square root of 4, that's 2. So I just solve for x now. I'm going to move the negative 3 over. I'm going to add 3 to both sides. So I get x equals 3 plus or minus 2. Now at this point I look, can I simplify it any farther? Because I'm going to have two answers. One it's plus, one it's minus. So the first one, when it's plus, 3 plus 2, that's 5, or 3 minus 2, that's 1. So that's where I get my two answers here, 5 and negative 1, and 5 and 1 from. And then in C and D here, we're going to get the squared part alone first. Get the squared part alone first. So I subtract 6 to each side. It's 2 times x minus 4 quantity squared equals negative 4. So I'm going to divide by 2. Again, I remember doing the opposite here to get rid of it. So I have x minus 4 quantity squared equals negative 2. At this point, how do I get rid of something that is squared? I take the square root. Now, can I take the square root of a negative number? Can I take the square root of negative 2? No. That leaves us with an imaginary number, which we are not dealing with yet. We're only dealing with the real numbers so far. So we say there is no solution. So once you get the squared part alone and then take the square root, oh, it's the square root of a negative number, it is no solution there. Now in D, if you look at it right away, ooh, I have negative 12 there. Well, you have to wait until you get the squared part all alone. So I move the negative 8 over. I'm going to divide by negative 2. When I do that, I get x plus 5 quantity squared equals 10. Can I take the square root of this? Yeah, I can take the square root of the left side and the right side here. So I take the square root of the left side, take the square root of the right side, and when I introduce a square root, it becomes plus or minus. So I have x plus 5 equals plus or minus square root of 10. At this point, can I simplify the square root of 10? No, it breaks down into 2 and 5. So I'm going to move the 5 over. I have x equals negative 5 plus or minus square root of 10. That's going to be my answer. I have two answers. Negative 5 plus the square root of 10, negative 5 minus the square root of 10. If it asks you for a decimal approximation, you could put both of those into your calculator as well.